Okay, 7.7, more separation of the variables, but this time we are doing particular solutions, meaning they'll give us given information so we can actually find the constant and find the actual equation that fits this criteria. Okay, so what did they give us? Okay, dy dx equals the quantity xy squared. Let me rewrite this. I need some space. Okay, I want to separate the x and y, so I'm going to go ahead and distribute the squared so I can get the variables separated, x squared, y squared. Okay, and then I'm going to move the y on the left, the x on the right. What is that? 1 over y squared. X squared dx. Okay, we're separated. Let's take the integral. Okay, let me think about this one. I'm not going to write it, well, I'm going to write it on the side. But remember, this is like y to the negative 2. 1 over y squared is y to the negative 2. So if I raise it, the power, I get y to the negative 1. And then I'm going to divide by negative 1. So I'm going to get negative 1 over y. Because it's negative y to the negative 1. Okay, I'm not going to bother writing the constant because I'll just put it on the other side. This is going to be x cubed and then divided by 3. So 1/3 x cubed. And then I'm going to go ahead and put the constant on the right side. Okay, now let me think about this. What information they gave me. They have given me that y to the 1 equals 1. And they gave me that information so I can figure out what the constant is. So I can plug in the 1, 1 right now and solve for the constant, or I can rearrange the equation, solve for y, and then solve for the constant after. It does not make a difference. Whichever one looks easier at the time is what you're going to do. I think I'm going to plug it in right now because it doesn't look that bad. Okay, so at y of 1 equals 1. I have negative 1 over 1 equals 1/3 of 1 cubed plus the constant. Negative 1 equals 1/3 plus c. Subtract the 1/3. Negative 3/3 minus 1/3, negative 4/3 is the constant. Okay, so I'm going to go ahead and plug that back in now. So I have negative 1 over y equals 1/3 x cubed, and then my constant is negative 4/3. Now, I am not going to leave my answer that way. I'm going to put it in explicit format. So I'm going to try to get it to say y equals. So let's do some algebra. What do I want to do? I don't like that y at the bottom. Let me see. I'm going to rewrite the right side as a one fraction because it has a common denominator. So x cubed minus 4 divided by 3. Okay, I could do cross multiplication, but given that the left side and right side are both fractions, I could also just flip them. I'm going to flip them. So y over negative 1 is negative y, and that's going to be 3 over x cubed minus 4. I'm going to multiply the negative 1 to the other side. Okay, so I got y equals negative 3 over x cubed minus 4. And that's the differential equation. No, that's not the differential equation. That is the solution or the equation that creates this differential equation with this initial condition. Okay, let's try the next one. Okay, find the solution, y equals f of x. So I do want my answer to be the form of y equals to the differential equation dy dx equals 2x over y with the initial condition f of 2 equals 1. Okay, let's start with our initial information. Okay, since there's x and y in here, I'm going to separate the variables. Y is on the left, x on the right. Okay, now that they're separated, let's do the integral. Okay, so that's y squared divided by 2. Okay, I'm not going to bother writing the constant since I know it's going to get moved to the other side anyways. 2x squared divided by 2 is x squared. And I'll put a constant here that kind of includes both of the constants. Okay, now they gave me the initial condition. What was it? That f of 2 equals 1. And f of 2 is the same as y. So they're saying that y is 2 when x is 1. Now I can plug it in now, or I can solve it and plug it in later. I think I'm going to go ahead and plug it in right now because it looks convenient right now. So 1/2 y is 1 equals 2 squared plus c. So 1/2 times 1, 4 plus c. Let's see. 1/2 minus 8/2 is negative 7/2. Okay, let's go ahead and, why didn't I write equals? Write the particular equation. I have 1/2 y squared equals x squared minus 7/2. Okay, and I don't want to leave it like this. I want to find the solution y equals, so I want this to say y equals. Okay, so I'm going to times multiply the 2 to the other side. Okay, and then I'm going to square root. When I square root, I get positive and negative the square root of 2x squared minus 7. Now, because they gave me an initial condition, I'm only going to use the part of the graph that includes this initial condition, which means I don't actually want the plus or minus. I want to know which one satisfies f of 2 equals 1. So if I were to plug in 2 here, 2 times 2 squared, 2 times 4 is 8, 8 minus 7 is 1. I want the result to be positive 1, which means I'm taking the positive part of the root, which is going to be the square root of 2x squared minus 7. And I'm doing that because this is a particular equation, and I want it to be the particular part of the graph that runs through that initial condition. Okay, let's try one more. Find the solution to the differential equation dy dx equals y plus 2 times e to the x with the initial condition y of 0 equals negative 1. Let's see. Let's move the variables around. I'm going to move the y's to the left. Let's take the integral. Okay. Let's see, if I do the integral of 1 over y plus 2, that's going to be ln of the absolute value of y plus 2. I'm not going to use u substitution because I would pick this as my u, and the derivative of du would just have a 1 in it. So I'm not going to worry about it. I'm going to worry about the constant on the right side. So the derivative of e to the x is e to the x plus c. Okay, let me go ahead and plug in my initial condition now. Y of 0 equals negative 1. So the natural log of negative 1 plus 2 equals e to the 0 plus c. What is this? The natural log of negative 1 plus 2 is 1. Absolute value is 1. ln 1 is 0. So c is negative 1. Okay, let me go back and put that in my equation. Okay, now I'm going to solve for y. I'm going to do e to each side. So this is, the ln's going to cancel. I'm going to get the absolute value of y plus 2 equals e to the x minus 1. Okay, we're going to go with that, even though it looks funny. I could do e to the x times e to the negative 1, which is e to the x over e to the 1, but I don't think that's going to make it any better. Okay, since it's absolute value, this could be a positive or a negative. Okay, let me move the 2 over, and then we will contemplate whether it is in fact positive or negative, because they did give me an initial condition, so I should be able to know which one it's going to be. Okay, what's my initial condition? My initial condition is y of 0 is negative 1. So when I plug in 0, I should get negative 1. So let me think about this. E to the 0 is 1. 1 minus 1 is 0. So e to the 0 is 1. When I subtract 2, I want to get negative 1. So I actually want to take the positive answer here. The positive one is the one that satisfies my initial condition.